Hi everyone, in this video let's see how you can just plot the data using Seaborn. So in the previous video we have seen how to install Seaborn and the introduction to Seaborn. So in this video let's see the distribution plots available in Seaborn. So from the name itself we can just understand, right? Distribution plots. So these plots will be useful to understand what's the distribution of the data set. We can able to know that. So that we will just discuss in this video. So before that we are just imported, you can see I just imported Seaborn as SNS, and to plot the data let's load the data sets present in the Seaborn itself. So in the Seaborn itself we have some default data sets, so let's load that. So for that we can just use load underscore dataset function. Load underscore dataset of, I will just give Titanic, right? So we have the Titanic dataset, so I will just load that in df. So if we just see what's the shape, how the column looks, you can see this is how the data looks like. Now let's try to plot the data. So for that, first let's use the distribution plot. So we can see SNS dot, we have the dist plot of. So this is the distribution plot. So this is very useful plot to understand the data, and you can see the description of this plot, right? So what are the arguments present in this plot, and all these arguments mostly same as set of this matplotlib. Let's give the data set here. So for that let's give df of age. Right now let's see how this age variable looks like, how it is distributed. How actually this dist plot will give us the histogram, right? Histogram of the variable which we just give, the data which we just give. So since we just given age, right, when I just plot this, so you can see the data, right? So you can see the plot, distribution plot. So from this you can understand what's the density, right? What is the density of each age? So you can see we have more number of people from around age 20 to 40, right? We have like around 20 to 30. We have more number of people in the Titanic ship. So we can see the data here. So that's the density. So that's how useful this distribution plot. So similarly, so this is how you can just plot the distribution plot, and there are few other variables as well, like bins, right? We have already discussed that when we like bins, right? When I just give bins is equal to 10, okay, when I just give bins is equal to 10, so it will just divide the entire data set into 10 equal parts, and again it will just plot the distribution. And similarly we have other variables, right? The same that of matplotlib, like whether if you want to change the color of these, like, right? So you can see that we have just changed the color, and you can see defaultly here the hist argument is true. It means that when you just plot this, automatically the histogram also will be plotted. So if you don't want histogram, if you just want only what's the shape of the distribution, so what you can just do is you can just give hist is equal to false, right? So if you do that, so you can see you will get only this plot, right? Or let's say if you just want only histogram, you don't want this density estimation, so what you can just do is instead of giving this hist is equal to false, you can just give kde is equal to false. So then you will just get only histogram. So this is how you can just plot the distribution plot. And next plot is a joint plot. So this joint plot is useful to plot two variables. So if you can see the previous plot, distribution plot, it will be useful to plot a single variable. That's why it called as univariate analysis. So since we are just analyzing only one variable, but now this joint plot will be helpful to analyze two variables. So let's see how you can just plot this. So to plot this, we can just use SNS dot joint plot of, and you can just give x and y variables here. So for that, I will just give x is equal to df of age. Let's take the x as age, and let's give y as, let's give x y as fare, right? Like the ticket fare. When I just run this, you can see the plot here, right? The x-axis as age and y-axis as fare. So you can see the distribution also, like how the age where data looks like and how the fare data look like. So you can see the graph, right? The histogram here, and also you can just see the scatter plot as well, like how these two variables are look like. So that's the use of this joint plot. So you can able to get the scatter plot in addition to the distribution plot. So through this scatter plot, we can able to understand is there any correlation between these two variables or not. Like, well, if there is any correlation, well, what's the correlation, like whether it is a positive correlation or negative correlation. So all those things we can get from this plot, and you can see the arguments as well, generally x and y, and apart from that the same, right? The color, like what's the height you just want, what's the x limit, y limit, all those things you can just play with all those arguments. And here you can see we have this, right? Kind is equal to scatter. So defaultly the kind will be scatter. So that's the reason you got scatter plot in addition to the distribution plot. Or let's say you just want, instead of this scatter plot, so instead of the scatter plot, if you want some other plots, so you can see we have this KDE, right? Kernel density estimation, like the plot which we just seen previously, right? And the histogram. Or let's say you just want all those, we have all those different graphs as well. So if you just want that, you will get that as well. So I'll just give kind is equal to KDE. Now you can see, so now you can see the plot, right? And similarly you can just play with other arguments as well. So this is the joint plot. It's a combination of you can just plot two variables in it, so that's why it's called as bivariate analysis, right? Since we are just analyzing two variables, this is the joint plot. And similarly we have other distribution plot, that is called pair plot. So in order to plot the pair plot, you can just use SNS dot pair plot of, you can just give the entire data, right? SNS dot pair plot of, I just given the entire DF data. Now let's see how this plot look like. You can see the plot, right? So if you can see in our data, we have few categorical variables and few continuous variables. So when you just give this, when you just give the SNS dot pair plot of, what it will do means it will just, so it will just take all those variables pairwise, so and it will just plot the scatter plot for those, right? If you just if you didn't understand, so if you can see, for example, let's take these six, let's take in our data we have these six continuous variables, right? Numerical, the data, these only these, for these six variables we just have numerical data. So if you just take that, then what this pair plot will do means it will just take every pair, like for example let's take survived and P class, and for these two it will just plot the distribution plot as well as the scatter plot. And the next thing, and similarly it will just take all the other combinations as well, like survived age, survived SIBSP, survived pass, survived and fair, similarly P class and age. So similarly it will just take all the other combinations and it will just plot the, it will just plot the pairwise scatter plot. So you can see in the, you can see in the diagonal wise we have the distribution plot, right? The histogram, and the remaining parts we have the scatter plot. So that's how this pair plot will plot the data. So even this is a distribution plot, right? Even this is also a different kind of plot in which we can able to analyze all the variables at a time. So instead of plotting each and every combinations manually, what this pair plot will do means it will just take all the combinations by itself and it will just plot the data. So that's how this pair plot works. So even in this pair plot we have some few arguments, like, so you can see even here we have the kind is equal to scatter. So similarly in the previous case, if you just want any other plots instead of that scatter plot, you can just do it. Or for example, let's say if you have any null values, if you just want to plot the data by dropping that null values, you can just give drop na is equal to true, so that it will just drop the null values. And similarly we have few arguments, right? And you can just do all the same things, like changing the color, changing the, like adjusting the height, setting the markers. All these things are same as that of the uh, previous plots. So that's this pair plot. So these are the three main distribution plots which we have in Seaborn. So I hope you understood how you can just plot the distribution plots, right? The continuous data in using Seaborn. So that's it for this video. So in the next video, let's see how you can just plot the categorical data using this Seaborn. If you understood the video, like the video, and if you haven't already subscribed to the channel, please subscribe, and I will just see you all in the next video. Until then, take care and thanks for watching.